I'm really thrilled and happy to introduce our two speakers this evening, Craig Stevenson and Jon McCann. Craig is president of the AUROS Group, a technology and consulting company based in Pittsburgh. As a Passive House professional, Craig is focused on integrating real and virtual data developed as the concept of evidence-based performance for the built environment. Evidence-based performance uses technology to bridge the gap between hoping a building is performing as designed to knowing a building is meeting its performance goals. With 25 years of construction experience, Craig is credentialed in virtually all known building performance standards. And trust me, he is. And is also an expert estimator. Craig is also co-author of the recently released book, The Power of Existing Buildings, Save Money, Improve Health, and Reduce Environmental Impacts. Well, maybe it's not so recent anymore, but it's not that long ago. And the ASTM article, Project Case Studies and the Lessons They Teach About Whole Building Envelope Air Leakage Testing. Craig holds 2 United States patents in the field of data science for the built environment. Everybody can't say that for sure. And last but not least, I have the pleasure of working with Craig in his capacity as the chair of the board of directors of the Passive House Network. Jon McCann is the CEO of the Environmental Charter School, subject of tonight's presentation, and is committed to the founding principles of the charter school movement in their role as laboratory schools designed to drive innovative practices that inform a wider public system. I think something we can all appreciate. Jon earned a Bachelor of Science in Elementary Education from Duquesne University and a Master's of Educational Leadership from the University of Pittsburgh. His career has spanned non-traditional educational settings and large urban traditional and public charter schools. Locally, Jon served as a science and language arts teacher for the Pittsburgh Public Schools before moving into the public charter sphere as the vice principal at the Urban League of Pittsburgh's charter school. An opportunity in early 2008 to build a new school from the ground up was the starting point for a journey that changed over time from founding principal to his current role in strategic leadership as the CEO. Jon is determined to evidence that ethics, transparency, collaboration, accountability, and a commitment to community service should be the underlying tenets of all good work, especially when educating tomorrow's citizens. Something I think we can all believe in. Thank you. Really looking forward to this. Guys, take it away.
Well, thank you very much. Yeah, Jon McCann here, and thanks. Lovely to join you from Pittsburgh, Pennsylvania, here in the U.S. And yeah, I appreciate that. I thoroughly enjoyed my breakout room, by the way. 2 Jonathans in my breakout room. What's the chance of that? But anyway, a little bit about the Environmental Charter School. We are a K-12 network, 4 schools, about 1,000 students. And really, if I was to look at our graduate profile, what would I want? You know, an eco-literate student that is a critical thinker, an engaged citizen, and a change maker. So that's who we're looking to graduate at the other end of our K-12 network. So a delight to be here, and we look forward to sharing a little bit about our project this evening. Craig?
Thanks, Jon. Ken, thank you very much for those kind words and that great introduction. I have to tell you, it's a pleasure working with you at the Passive House Network to advance Passive House for All. So really appreciate all the hard work you're putting into. We look forward to the conference. And with that, let's jump into our presentation. So Jon and I are here today to talk to you about our project that we're planning for the Environmental Charter School of Pittsburgh. It's a new high school. And we're going to go through and walk you guys through the thought processes and our goals and targets for this new project. So we'd like to start off by introducing our project team. Our project team, when we went through the project delivery here, we wanted to onboard a team that was experienced in Passive House. We've been doing this on a few projects now, and we know firsthand onboarding the right team makes all the difference in the world. It makes all the difference in the world from a first cost perspective, from a schedule perspective, and from getting through the passive house criteria as quickly as possible without going back through rework. So we came on board originally with John's team. We helped them with a middle school project, and we sort of rolled right into the high school project. So we've been on board early and first. We created our goals and targets through an owner's project requirements, and then we drafted the RFQ to onboard the rest of the project team. Our project architect is Avon Design Group. These guys have done, I think this is their third or fourth passive house project. These guys are steeped in passive house. They understand this process extremely well. And I got to tell you, it's making all the difference. Our MEP, FP, Mechanical, Electric, Plumbing, Fire Protection Engineer is HEPE Engineering. HEPE has not done a passive house project per se, but they've done net zero. They understand an envelope first approach, and they literally have bought into it. And getting an MEP to buy into the passive house criteria, again, makes a world of difference when you start targeting passive house criteria. Our system integrator, this is a project that's pursuing smart building infrastructure. So we're going to talk about that in a little bit, but our designer for that is Newcomb and Boyd. They're taking on the system integrator role. And then a structural engineer, Atlantic Engineering, I believe these guys have done at least 6 or 7 passive house projects. And again, having a structural engineer understand the thermal bridge criteria for passive house and how to approach that. What we've done on this project, which is really cool with Avon and Atlantic, is we're really using quality design to eliminate the crutches of Armatherm and other thermal break materials like shock. We're just keeping all the structure inboard, which makes life a lot easier. And then to fill out our role here, Gateway Engineering is the civil, and the food tech is Trimark and Forward Design Solutions. For those of you who don't know Forward Dining Solutions, Chef Galarza runs that group. And when you're doing a passive house with a commercial kitchen and a teaching kitchen, you're going to want to look for Chef Galarza and his team. These guys have done it before. They understand how to plan for the kitchen exhaust systems and the electrification of a commercial kitchen. So again, this team here is really steeped in passive house, and they've all bought in and are leaning in, which we're excited about. Here, I'll get to that in a minute. So let's get into the job.
Thanks, Craig. I get to sit back here for a second or 3 and admire this building. It's just lovely. So, this is my slide before the acronyms start and the engineers jump in. So why am I so proud of this building? Why, as an educator, this building, this school, it represents a couple of things, right? A set of commitments to the following things, really. Certainly to our region and our city's journey to reduce the overall carbon footprint, and that's something to be super proud of. It certainly commits to the health of our students, our employees, and the community members that are going to use this public building going forward. And as was mentioned earlier, we're a charter school, and charter schools have a distinct role in public education in the US, and that is to drive innovation in public education. And I see this building as an example of a next generation healthy and green school. And all built within and on public school budgets and tax dollars. And so that is a terrific commitment and a terrific part of this journey. Secondly, that this building embodies the mission and values of our educational institution. It's a dynamic teaching tool, or it's a teaching tool that is dynamic and provides data every day that allows students to engage in and manipulate, and lots of evidence there. It allows our students to engage in air quality conversations and research and around energy and storm water management, through that sort of marriage of passive house and reset air. And just a note, if you don't know, the environmental charter school starts at kindergarten and journeys right the way through to 12th grade, and that's a big commitment under this heading. And so our little ones, for instance, our kindergartners, we push out and they get involved in design, right? So there's a unit, our school teachers that little ones look at playgrounds. These are pre-readers, and they look at playgrounds, and they feel playgrounds, and they look at playgrounds from across the world and understand what they feel like, and discuss them, and they build them and meet architects, and ultimately present to their parents. And in our middle school, we have a course where 6th graders are designing buildings. 7th graders go out and think about how you design a city and the infrastructure and the systems associated with that. 8th grade getting into performance and building performance and things like passive house and well and beyond. So, and then when we get to high school, and this is the building we're looking at right now, that we're encouraging kids to get involved in civic life and get thoroughly engaged there and impact change. And so that is what this building represents, all of that, and that continuum from kindergarten through 12th grade. So we're enormously proud of that work, and the fact that this is going to be a passive house and everything underneath that. So, Craig, you want to add to that?
Nope, we're good to go, John. That was a great explanation. I'm just going to advance the slides here. This is our site plan for the project. As you can see, this is urban infill, which is a core mission for the Environmental Charter School of Pittsburgh, is to stay within the city of Pittsburgh limits. So this is in the East Liberty section of the city of Pittsburgh, and you can see there's alleys on both sides and a major street in front, and there's buildings directly behind us. So massing and orientation wasn't really an option. We had to really go after window to wall ratios and other criteria to try to help ourselves meet the envelope performance requirements of passive house. But this is exactly in line with the Environmental Charter School's mission for urban infill.
And there's that elevation, and we begin to sort of take a look at some of the features here. You'll see off to the left an outside classroom space. Outside space in a tight building like this is really golden. So we built in some outside space and terracing for outside classrooms and meeting space. And then up on the roof level, we have a number of outside spaces that are attached and flow out of various different classrooms and labs. So we're in the first floor here. So if I guide you off to the bottom right, which is where our main entrance is, flows off a busy street. Great sight lines there. We have a central atrium sort of feature in the middle here. So we've avoided this notion of that wraparound corridors in school. We want a wide open space, and you'll see that flowing right through the center of the building. It provides a number of opportunities for some FF&E creations for students. These are adolescents. They don't like to be seen. They like to huddle. And that wide atrium provides that opportunity for us to design spaces for those folks to meet and for adults to meet, and faculty too. If you sort of move through that atrium, a number of features there. There's the cafeteria off to that, into that open space, sort of top left, and right there. And that is an open plan. It backs on into a from scratch kitchen with all of its complexity there. It also flows through to the right of the cafeteria into a courtyard. And that courtyard, it provides light. It's an outside space. It's one of those great privileges. When you get to a certain grade, you get to eat outside. But ultimately, it provides a light well that runs right up through the building, providing light into the building. It also flows through to Black Box Theater with entrance off to the right. So that has a beautiful flow to it. We're onto the second floor now. And again, large atrium right the way through. The light well coming up through that from that courtyard is going to provide light through and into the building. Again, you see here some FF&E solutions, if you want to call it that, but some gathering spaces that provides additional places for adults and kids to gather. Again, we've avoided those hallways that are narrow and run one way. We've got two-way traffic there. You'll see some faculty co-working spaces in here as well that we've committed to. and then science labs along the back wall. And of course, those science labs, one being a chemistry lab, we've had to circumvent or work with the venting challenges there. Onto the third floor there. Again, a lot of FF&E, you'll see solutions and seating right in the middle. The light coming up through the courtyard. At this point, you're going to see the bottom left there, this outside classroom gathering space. Again, that's a theme through the building. We're a tight space in this school. It's very much an urban setting, so building in that notion of being able to get outside, it's important for young adults as well. And so we head to the fourth floor, and the fourth floor is a lovely space to be, right? At this point, we're getting some great views over the city of Pittsburgh. There's some labs right in the middle, an environmental science lab that runs out to gardens. At a future point, there will be a greenhouse up here, raised beds, and certainly solar will be a part of this landscape at one point. We have off to the right some more gathering spaces, bathrooms, of course, but also some spaces for faculty. And so faculty get to plan, to be around each other, and we build in those spaces as well.
All right, thanks, John. And as you can see, I mean, the goal for the charter school is to make sure that the students are able to get outside. I mean, John, what's the number? About 50% of the time students are spending outside at the environmental charter school?
Indeed, yeah.
So we used a lot of outdoor spaces in the building to help achieve that, but there's also parks and walks that are close and adjacent that we're also planning to incorporate into this design as well. So the idea here and what we want to talk about is the approach we've taken towards the environmental charter school is to merge building science with data science. And the building science side of this is passive house envelope first strategies, getting at the most efficient building we can build pre-renewables. The data science side of this is to set up the building with meters and sensors that can give us feedback loops to know whether or not John's getting what he paid for. That is how we get to zero energy and zero carbon and world-class indoor air quality over the life of the building. This isn't a matter about designing a high-performance building. It's not a matter of constructing a high-performance building. It's a matter of operating a high-performance building for the life of this building for 75 years. That's why we're incorporating data science and building science together into this project. And we'll talk about that in a few minutes.
Yeah, Craig, I mean, anyone that knows anything about Pittsburgh, we don't live in the cleanest space. We have some serious air quality issues and have done many days over the course of the year are coded in such a way that we encourage the students are encouraged to play inside. Building this building, of course, as I mentioned earlier, is a commitment to that.
Absolutely. So as we start to lay out our goals for this project, I put this slide up here almost as like a tongue-in-cheek joke, right? When we work with project teams and we get into our architectural programming, typically you see an owner's project requirements, an OPR, if you will, that's based on narrative, right? It's 25 pages, lots of words, and everybody does the charrette and they feel really good and they come out of this thing and everyone's charged up. Next thing you know, the OPR gets set on a shelf and it collects dust until the project's built. This is what it looks like. And these are all great words. If you read it, you're going to be like, wow, this is really, really interesting. It doesn't serve us well for the project that we're trying to build. And I'll explain why. We cannot create a narrative and expect our team to get aligned around that narrative. Because as soon as they hit the first bump on the road of schedule or cost or complexity within the job, what's the project team typically do? They revert back to code because that's all they know how to do. So we have to change how we align our project teams. We cannot use narratives like this. We can use sustainable certification programs, but again, these are limited, right? These are not always aligned with everything that John wants to get out of his building. For this particular project, we are pursuing PHI and FIAS. We're doing both. That's unique. And we're doing it because this is the environmental charter school and they want to use this as a learning laboratory. We want to learn. We want to understand. We want to create a measurement verification system to give us a feedback loop so we can get better and improve what we do. This building will give us all that data. This building will also be Reset Air certified. This is an air quality continuous monitoring program. If you haven't learned of Reset Air, I urge you to take a look at it, Google it. This is really where the puck is going in terms of air quality in buildings. And reset air is symbiotic with passive house because with an envelope first strategy, as most of this community knows, we control infiltration and exfiltration. If we do that, we can bring the air into our buildings through ductwork and filters that we manage. That gets at air quality almost immediately, which makes reset air really an easy button. This building will also be a pilot program for the well performance rating. We're one of the first projects to pursue the standard because we will be a smart building and we want to tie a lot of our technology back to those feedback loops. But again, this isn't enough. Where we end up going is we go to a metric-based owner's project requirements. I am more than happy to share this with anyone in the community. If you LinkedIn to me and send me an email, I'll share you this document because it doesn't do justice to see it on a presentation like this. The idea, though, is very simple. We identify all of the high performance building elements that exist. Energy, air quality, and indoor environmental quality. The difference between IAQ and IEQ is light and sound. Material for both toxicity and embodied energy, waste, water. I mean, it gets at every element of performance. And to the extent we can, we identify metrics. Why do we do that? If we set up a project with goals based on metrics, then all of a sudden we can energize and align our project team to design to those goals. We can then set up our measurement and verification system to give us feedback loops on these goals. It's the common thread through the entire process. It cuts through every silo and it gets to build high performance buildings very, very quickly. And if we hit a budget issue or we hit a complexity, we use this OPR to basically go back and prioritize our goals. And this is how we make decisions. With a narrative, it's too hard to figure out what do I cut first, second, and third. With an OPR based on prioritizations and metrics, it makes it much, much easier for us. So this is what Jon was talking about, right? And for this community, we don't spend a lot of time talking about passive house. This is more of a case study type presentation. But the idea here is we're using envelope first approaches to get at energy. When we do that, we solve other problems, right? We solve our air quality problems, as I just mentioned. We solve our sound mitigation problems because being in a passive house, it's extremely quiet. And we solve light because we manage our window to wall ratio and the light that comes through, light availability that comes through those windows. So again, using an envelope first approach is the foundation. It's the infrastructure and how we pursue all of our project goals. It has to start with that. Otherwise, if we don't have the right envelope, we end up spending a premium to get at the rest of the goals. So this has been really the key and the secret to get at a whole building performance across all elements of performance. So how do we do it? Again, we talk about this and we start early. Everybody in this community has talked about the value of integration and the value of early starting. And we wanted to reinforce that because it makes all the difference in the world. When we had set out to do the Environmental Charter School of Pittsburgh, we set our goals in before conceptual. We use those goals to write our RFPs and RFQs for our design team. They are coming in understanding exactly where we're going on this project. Now, the OPR is a working document, so it's not cast in stone. It's not intended to be a fixed document. It evolves, just like a project schedule would evolve. So as we go through and we make decisions, we update our OPR. So when we send out our RFQ, we send it out with a baseline RFQ, the baseline owner's project requirements report. And then as the team gets on board and we start getting into early design, we update that as we go forward. And the idea here is we start very early, we model, and we then create a control estimate. And we're doing them simultaneously, continuously, and iteratively. So every time we get in and we do our massing and orientation, we check the model, we check the price. We do our envelope optimization, check the model, check the price. We do our system narrative, check the model, check the price. We're doing this literally, we're making all of our big decisions before we even get halfway through schematic design. And for most architects that, learn about passive house and they try to start figuring this out, this is not normal for them, right? These guys are used to basically going all the way through schematic before they almost ever engage in MEP. And then the MEP comes in and they have a fixed envelope, fixed loads, and they go do their job. That doesn't work in a passive house project. You have to be collaborative and you have to be early to make this work. And again, if you're going to start talking about smart building infrastructure, you better talk about it early. If you don't, you'll pay a premium. We talk about it very, very early in the process and how we want to set up our building. And I'm going to get into that in a minute. So why do we do that? This is called the McLean Curve. The cost of money is cheapest early. If I want to change a door and I want to do it based on drawings, it's a matter of getting an eraser out and moving it. If I want to change that door after the building's built, it's a whole different matter. It costs a lot more money to do that. So the idea here is we want to set our goals early. We want to start getting into iterative modeling and iterative estimating literally in early SD. If we can do all that heavy lifting early in SD, we've saved ourselves a ton of effort and a ton of money in that process before we ever get way out into even construction. And we cannot view measurement verification systems as post-construction issues, or FF&E as John calls it, furnitures, fixtures, and equipment. We have to think about this early, and that's what we do. So when we talk about smart building infrastructure, a lot of people think, okay, we're just buying a really sophisticated building automation system, or we're just buying a system in the building that might do something different for us. It's more than that. It's about getting at the data. The whole goal here is we want to get to all the building performance data into one independent data layer. If we can do this right, we can set up our operational technologies to be open integrated, meaning non-proprietary, that we can bid out our service agreements, because that was important to John. They don't want to become beholden to a vendor for 20 years. They want to be able to compete those in an open way. We can then develop a converged network. A converged network combines the operational technologies, building automation, security systems, fire alarm, water meters, reset air sensors, into one network. Everything is an IP network. We use virtual LANs to segment that so that we can manage the data so it doesn't commingle. And then we save ourselves a lot of money in conduit and wiring, division 27, if you will, that we don't have to run 25 networks in our building like we traditionally do. We're able to save a lot of money in conduit and wiring and convergence of these networks that we reinvest back into additional measurement verification systems. And that's how we were able to get more value out of the processes because of what we save in converged networks. It's like in a passive house, taking our money that we save from MEP and putting it into our windows, for example, right? It's no different. We're taking money in a value prop and we're moving into another area that we want. The data aggregation is really the center of the universe in a smart building infrastructure. And if you guys are familiar with this, this is typically going to be a Vicon Niagara Jace or a Distech appliance. But these are open integration appliances that anyone with the right credentials, capabilities, and qualifications can go into and work on without paying a vendor, an exorbitant amount of money to do that work for you. Then we get the data into our independent data layer, which then can plug into any of the advanced data analytic capabilities. And what we do is we bring all of our exported simulation and a dynamic energy model, and we use it as our context for performance. So this is how we set up buildings for smart building infrastructure, and this is how we can do it at par for costs. So this is a slide that everybody else is familiar with. I wanted to add a slide in here for our costs, but we're just not in a position to do that yet. We'll be ready to do that in the next project. But we're seeing basically the same kind of construct here in terms of managing our costs. John had set a budget early on for the project. That budget had to be modified for the current challenges we have with escalation and material availability in the marketplace. But short of that, our budget has been the same from day one, even though we're layering in passive house and smart building infrastructure into this building. And we're doing it for a lot of those reasons I mentioned earlier. This slide here is an example of PHFA's costs. I'm sure you guys have seen this a few times. If you've been in the accelerator, this has been presented a number of times. The PHFA talks about in 2015, they set up criteria for passive house. The first year they were spending in conventional construction, $159 a square feet, and passive house, $169. There's your premium. That's a learning curve. Then they went to 170 to 173, still a little bit of a premium, but much, much closer. And then by 2018, they were actually building at a par. And again, what we argue is if you build the right team with the right experience, you should be able to do this all the time. PHFA did not publish data in 2017, and we're waiting for their 19 and 20 and 21 data to come out. So that's why we still have this data. So then we talk about this smart building infrastructure and how do we get at context. Historically in smart building infrastructures, we're using history of data as our context, or we're using CBEX comps, right? National median. And we argue that that's really not the proper way to start looking at buildings. If we're asking John to make an investment, then we don't want to tell John you're better than you were last year, or you're better than you were the last 3 years. The question John's asking us is, did I get what I paid for? Is my building performing in the way in which it was designed and constructed to pay for? The only way we can answer that question is using dynamic simulation. So the PHPP and the Whoopee passive models for Passive House don't get at dynamic simulation. We bring up an IES-VE energy model, and that does get it to sub-hourly data that I can export for all forms of energy and for temperature and humidity and CO2. And I can do that by zone, by use. Anywhere we can set up a meter, I can set up a simulation in IES, and I can export that. And it gives us the context into, is the building doing what it was supposed to be doing? That's how we view the world when we talk about merging data science and building science. And when Ken mentioned early on in the introduction, we have patents in this space, this is where we're patented. We're patented in the integration of simulation and trended data from any dynamic physics-based model into any independent data layer. This is what it looks like when we start going into practice. Again, we can show this to you for all the different forms of energy and IAQ, but this is just simply for gas. And what we're looking at is this is basically sub-hour data that rolls up and it rolls down with our trended data on any dashboard. We can set up notifications and alarms to the facility manager so we can get action if we're missing our targets. But most importantly, we know in real time, is the building performing as it's supposed to perform? What else can I do with that data? So if we're getting at dynamic simulated data, again, we talked about the value of using it for monitoring-based commissioning, but I can also use it for interrogation-based commissioning. And think about that. When we have a gap in performance, what do? We look to retro commissioning. We bring boots on the ground into our buildings. And we spend hundreds of thousands of dollars to blindly try to find out what's going on. It's far cheaper and easier to use the technology we have in place to identify those gaps. I can go into an IES-VE model and say, okay, maybe you change the BAS system and it's no longer working 8 to 5, but it's working 24 hours, 24/7. We can set up the model, run a simulation, drop those targets back into our data layer, and we can see that instantly. We can run dozens of simulations very quickly and very easily to start to identify those performance gaps. And if you've ever heard of advanced analytic testing, fault detection and diagnostic and other testing like that, we can test those analytics in the virtual environment before we ever deploy them. What's happening today is we're setting up, say, CO2 on demand. CO2 goes high, I want my fans to turn on. Well, when we set up those as analytics and put them into our buildings, if we don't test them, then we're using our clients as the guinea pigs to see if they work. And what we argue is, why do that at all? Why inconvenience our client? Why not test this in the virtual environment before we deploy it? That's what we do. We can also set this up for independent and proprietary data layers. Where this goes and what platform this in, we're relatively agnostic to that. This is an example of using CO2 to identify those gaps in performance. And when you see this peak in that blue line, we want to know what happened there, right? Obviously, there's a lot of people, an event happened, the fans didn't kick on, something happened that made CO2 spike. Now we have the opportunity to fix this in real time. So with that, we're happy to answer any questions you may have.
Thank you, John and Craig, for a fantastic presentation. I'm never disappointed. I'm always learning something new when you present. And I took some notes. I threw some links into the chat at my best guess on some of the items you were mentioning. So please let me know if my IES energy modeling software link was correct. And we'll get right into the questions. The first one from Jeffrey. Jeffrey, would you like to unmute and ask your question?
Great. So I actually put 2 questions in there. Am I allowed to bundle them together?
I think we can let that happen tonight because we don't have a ton of questions yet, which
Okay. So
I will prompt everyone by saying, please throw your questions in the chat while you have these 2 wonderful presenters here to answer them.
So the first question I have has to do with, I think it's called the California High Performance School Standard, that is very much adopted as the standard for designing schools. And I'm wondering if, how does that fit with the Passive House and the other standards that you were shooting for? Is it higher, is it lower, that kind of thing? So that's one question. And then the other question I had got to the density of, which is very much a cost thing I think the policymakers care about, which is what's the, space per square, or the, students per square foot standard, and how does that fit with the design and that kind of stuff?
So let's take them one at a time. And I'm looking here. I believe we have one of our architects that might be joining the line, because I might defer that second question to them if I can see if he's here. The first question around the California standard, I can't speak to that. I don't know. I do see that there's some people from California here. If anyone has an answer to that, please feel free to come on and see if you can help us out with that. So I unfortunately, Jeffrey, I wish I can answer that question, but I don't know the California standard, so I don't know. Around the densities for square foot, I did see Jeff Light with Avon Design Group here. Jeff, if you're available and able to come off mute, maybe you can help us with that question around the density of students in the building. He might be unavailable, so I don't have the answer for that either.
Oh, well, we'll take it offline and we'll get answers later. So
if you shoot us an email, I'll definitely get the answer for you. I can get it. I just don't know that answer off the top of my head.
That's great. So is your email address going to be in the chat, or can you add it into the chat? That'd be great.
You can message on LinkedIn, I believe.
Okay. Well, yeah, but if his email is in the chat, then everybody can.
I'll put it in there now.
Okay, great. Thank you.
You bet.
That's very kind of you, Craig. I appreciate that so much. Our next question is from Janet Price. Jen, are you with us? And would you like to unmute and ask your question? And if not, I can ask it for you. She was wondering about the natural lighting in the rear buildings. So maybe that has to do with the orientation.
So the natural light, because we're adjacent in the existing building behind us, is one of the reasons why we placed the courtyard where we placed it, so we can have that light well in there. Every room has windows. Every room has access to light. When we come up above grade, we do have lights. We have windows on those back walls. That back building only goes up, I think, 12 foot, which is literally through the first floor. So second floor all the way up to the fourth floor has windows on all four sides of the building. Now we manage that window to wall ratio and the fenestration to balance on the passive house criteria, but we absolutely have windows in all four sides.
Perfect. Thank you, Craig.
Thank you.
Next question is from Enrique Bueno. Enrique, would you like to come ask your question?
Yeah, it's related to that. What was the window to wall ratio that you ended with?
I don't have that figure. Sorry. We weren't going to go super technical with the case study presentation today. I can get that answer for you, Enrique, if you send me an email. We
Sure.
have that in the model. I just don't have that information right at my fingertips.
Okay, thank you.
I would have
Great
to
presentation.
assume, I would have to assume we're 25 to 30%, but I don't want to give you the wrong number. So if you email me, I'll get it for you.
Okay, thank you. Great presentation.
Thank you.
Next question up is from Derek Calburn.
Oh, hey guys. Hey, Craig and John, by the way, fantastic. As everybody knows who's seen me on here, we make a data-centric lighting system. And so, and of course, my background's in building automation controls. So I'm really excited to see a little bit of that creep back into passive house because, you know, we say put a little active in your passive. And a lot of times I'm concerned that in a lot of commercial buildings that the MEPs, the control systems, kind of try to compensate for faults in the mechanical design. And what I've discovered beautifully is that, you know, passive house is so well defined now that the controls guys don't have to compensate as much for bad mechanicals. So that was a piece of the question, by the way. But the other thing I was asking specifically about was, did you guys also focus on any studies around the lighting with respect to human-centric lighting, et cetera, so that you can kind of compensate for the maybe lower window natural light amount?
So our OPR includes specific light densities that are consistent with the well building standards. That's the criteria that we followed. So we use passive house criteria to manage the fenestration window to wall ratio and the placement of those windows for solar gain. And then we use the well criteria to go for a light availability, access to light, and light autonomy using the well concepts. And they were all vetted out in our IESVE model.
Anything that it's, I know Well is kind of looking into those things, but I don't know if it's defined yet as far as the color tuning and things like that. I mean, certainly it's relevant to the industry. You know, we kind of build it into all the fixtures, have the color tuning capability.
Yeah, we did not, when we went through light, we did not have any goals established for circadian rhythm or the color of the light. We're leaving the engineers use best practices around those parameters on how they solve for that, but we did not go for any kind of circadian rhythm using the well concepts for that.
We had some good questions from Jesse Walton. Jesse, are you still with us? And would you like to unmute?
Yeah, I'm still here. Great presentation. I'm an architect in the Pacific Northwest in Seattle at Malum Architects. I do a lot of school projects up here. And so it's great to see more passive house commercial school projects being designed and built. Questions I had, one was around, I think it's great that you're having all the data be open source and trying to integrate that data into the educational curriculum at the school. I was curious how you're doing that. A lot of the data I see coming out of building automation systems is looks like it's out of a website built in the 1990s. Incredibly unintuitive, hard to pull out, hard to integrate with educators. So just curious how you're planning on doing that.
So that's a really good question, and that's something that was really a goal early on for ECS. So the first thing we're going to do is we have all of our data in a independent data layer. In this case, it's going to be OSI Soft Pi. If you're familiar with independent data layers, that's a really robust system. And that system can share data literally anywhere. So we are collaborating with a couple local universities in Pittsburgh, University of Pittsburgh, Carnegie Mellon University, and Chatham University to provide data to their graduate students that they can start to teach data science. These students are coming out of college right now, and they want to be able to work on time series data, write the next analytic, write machine learning, write artificial intelligence. But yet when they do this, and we know this because I've been talking to them through these projects, is they're using mock data because these universities don't have smart buildings. They don't have passive house and smart buildings. So they have limited data and how they're able to do this. So John's vision is to set up ECS so that it becomes the hub that has an open infrastructure that we can permit universities to come in and start using this building as their testing lab. CMU develops a ton of sensors, IAQ sensors, combo sensors. We want them to put them in this building and use that as a laboratory because they can get data right back out of it that quickly and easily, and we can start using it as a testing environment. So you're right. I mean, getting BAS data directly to high school students might be a little challenging, but we're automating our site source cost and carbon and water use intensities. We've automated that in our systems. That is not too complex for students to understand. To understand what is the site EUI, how is it calculated, what's the difference between code-based construction and the pass box, and how is this improving decarbonization of buildings? That subject matter is center place for high school students. So we're able to start teaching them the value of energy using data, and then indoor air quality. You know, why is CO2 above 1,000 ppm considered bad? Well, we can now see it. We're going to see that data in real time for particulate matter 2.5 and 10, TVOC, total volatile organic compounds, CO2, temperature, and humidity. So now all of a sudden they can start looking at air quality and energy as two primers, so the low-hanging bars there to basically start figuring this stuff out. Plus, they're going to have access into the Pi system too, so they can go in there and start looking at how are analytics actually written. How do we write an analytic for time series data? So the idea there is there's data science pedagogy, there's environmental pedagogy, and then there's understanding what is carbon in a building and, you know, operational carbon versus embodied energy. Those are all what we're going to be bringing into the pedagogical conversation. And our students at the environmental charter school are then able to mirror the college schools because they're using our data, and there's a reciprocal relationship there that our students should be able to go in there and mirror that and start taking college level courses in 11th and 12th grade and start understanding what the heck they're doing in the next 4 years. So those are all the things we're looking at right now in terms of how we're going to talk about this. But more importantly, Jesse, and I'm glad you asked this question because it opened the door and everything John and I want to talk about, is that this is not just going to be available to universities and to our students, but it's going to be available to the passive house community, because this is really going to be the project we hope that people are going to go back and start saying, you know, how many times have you heard people say, well, yeah, you build a passive house, but what's it doing today? You know, what's your EUI right now? We'll be able to see this in real time. We'll have a public facing dashboard. It'll be read-only data, but it'll be public facing. We'll be able to share this data.
You guys are designing that dashboard yourself?
Yeah, yeah, the dashboard's going to be multi-pronged. So, you know, we're contemplating right now, we're seeking funds from a foundation to put in a NAST machine. A NAST machine is an outdoor air quality machine. And, you know, that measures things like SOx, NOx, ammonia, ozone, CO2 of outside air parameters. If you look for that right now in your community, and I look for it in our communities, they don't exist. The federal government claims they have these machines, but yet all they have is a parameter of 2.5. And it only has 2 months of data because the other 12 months or 10 months it's broken. What we want to have is a machine that's fully funded by a foundation. It's in a smart building that's a passive house and smart building, and it's public facing. So now all of a sudden, if someone wanted to come in there and get that air parameter and prove that Pittsburgh's in the 3 percentile of air quality in the country, which we are, now we can start to see why do they say that and what does that mean. So it's things like that. We're going to open and make available our operational technologies to make them public facing. We're going to make our whole building performance data public facing. And we're also going to open up the models, all 3 of them, because we have a WUFI passive, we have a PHVP, and we have an IEF. And then we want to start comparing what is the difference between them. When we look at these models across these certifications, you know, why does FIAS, you know, devalue plug load densities and PHI puts too much in there? Because that's the common argument you hear. We're going to be able to see that, and we'll also see it with the context of the measurement verification system. So again, these are all the things that we are having plans right now, what we envision the environmental charter school becoming.
Yeah, and there's a challenge in the middle of that, of course, right? You know, we're setting up our students to understand what a passive house is by the time they walk into that new building. But we're catching up with faculty too. So we're pulling a cohort of faculty to train them on what it means to be inside this building, what it does, what it produces. And so there's a real lift there, but it's enjoyable work.
Yeah, it's
Such a
learning curve
brilliant
for all.
answer. Jesse, did that answer your question?
I think so. I could probably keep talking about it for a long time. But
Oh yeah,
I'll
we're
let
not
everybody-
letting this subject go. Oh no.
I know Mark is all over it because of everything that we've talked about in the past with Women Cash, because that's what you guys are doing is exactly why we are trying to, you know, make a product that provides the data capacity. In other words, you know, lighting is ubiquitous, and so you have to have it everywhere. PoE lighting, you know, allows you to put those kinds of sensors in everywhere, right? But the problem with PoE specifically is that it's expensive, and it's, you know, and there's other efficiency issues. The, you know, CLTC has done a bunch of studies and shown the efficiency isn't so hot. But, you know, with what we created here, we've got the opportunity to put it in there. That's why I do that silly tagline of, you know, put a little active into passive. So I'd love to follow up with you guys as far as, you know, extending your, not only your open source software that can be pushed into other buildings, but also the fact that, you know, I'm happy to give you guys some hardware to play with so that the students can, you know, show that we can attack, you know, and get many, many additional data points into your models. As I said,
Thank
we're
you, Derek.
out there, especially with the IAQ sensors that we're making. So by embedding the IAQ sensing right into the light switches, it just kind of, it makes this nice platform that you guys can play with more. And because we're doing the same thing in the UK as far as getting universities involved. So yeah, I'd love to work with you guys and help with that.
So Derek, we're actually looking for actively right now cost-effective DBA sound sensors and light sensors. DBA sound sensors are expensive inside buildings, really expensive. So if you have any thoughts on that that you can share with us, we're all ears, because that's been something we haven't been able to find cost-effective solutions around.
We do. In fact, the multi-pack sensor, so the one that has the indoor air quality, it's got a light and sound sensor in it, because you know, when you look at all the elements of passive house, a lot of times people forget that it's also sound. You've got a lot of sound abatement that goes on. And I don't know if you guys can see where I live here, but it's loud as all hell. That construction site's been going on for the last, you know, since COVID, and it's just constant bang, bang, bang. And all I can think about. Every week I'm reminded about, passive. It's like, oh, why didn't they put good windows in here, So, but yeah, actually there's many, many uses for SPL meters inside of, because you can have not only about ambient noise, but you can also detect other things that are going on inside. So in schools in particular, you can detect activities, you can detect crowd requirements, active shooter problems, things like that. There's all kinds of additional benefits that you can get from having the sound meters. And something I posted a couple of months ago was a sneak peek of that sensor. But I'll be happy to let you guys get a couple of alphas with it so you can play with it.
Yeah, Derek, if you could send me an email, I definitely want to connect you to our Div 25 engineer, Newcomb and Boyd, and make that connection. I mean, we have a lot of technology going in here, but again, we're not over technologying the building, if you know what I mean. I mean, we're not putting in meters and sensors for the sake of meters and sensors. We're connecting use cases from our OPR to our meters and sensors, which makes it a cost-effective deployment. So we have density analytics, we have all the normal stuff like building automation, fire alarm and security, but we have density analytics, we have energy meters and submeters because there's only electric in this building, there's no gas. We have water submeters, and we have the reset air sensors. We're missing and we're a little weak in the light and sound. So to the extent you can share some information with us, I would welcome it. My email's in the chat, and please reach out to me.
I did follow it, yeah, and I'm happy to. It seems like the perfect meld too, because that's exactly our focus. It's the light and then the additional sensing.
Yeah,
and I did really
cool.
appreciate you guys' approach to this too. As I said, I came from the building automation group, so I ran a big 50 building pharmaceutical campus. It was my first job, and so what I had always found was that the mechanicals, as I said in the question, we used to compensate for mechanical problems, and mechanical guys always loved us because we could compensate for most faults in design. I think as the world progressed and the design teams got better and better at it, and then in particular the passive house education has gotten out through groups like PHA, et cetera. It seems like you guys are really dialing in the mechanical design now, and so the low hanging, or the gaps, I should say, are things like failures. So when a filter starts to foul, when a device fails, that seems to be the biggest challenges now. So I'd love to hear what you guys are doing as far as failure analysis and predictive analysis too on failures.
Yeah, so that's an easy answer, and I can show it to you and do a demo for you. But our independent data layer has a connectivity to SkySpark. SkySpark is a fault detection and diagnostic platform. And we also are making a connection to Code Labs. Code Labs is a digital twin that does digital twin concierge type stuff. So we're making those connections to those two. And think about it, it's one pipe from our independent data layer to them, right? So now all of a sudden, I don't lose infrastructure, I don't lose capabilities, I don't lose history of data. If we want to pivot and move to another vendor, we just cut the pipe and we go somewhere else. But right now, SkySpark, we found, is doing an excellent job around the fault detection field. And we've imported them, and we're using something like 76 roles right now on those. So I'm more than happy to demo that for you and show it to you.
The Code Lab guys we're working with, so if you've got a data pipe over to them, they can import our data. Data's data. It's pretty easy to share it nowadays.
Yeah, Shannon, I just saw a pop up on the chat. It's KODELABS. Code Labs is the name of the digital twin. Thank you. Appreciate it. But Derek, yeah, those guys are great guys. We find their platform is one of the better platforms that we've seen in the market so far. But the problem is, if you don't have an independent data layer or your infrastructure set up the right way, they come in and become an SAS, a software service, and they own your whole building. We don't want that. We don't want, the blue needle of death for 20 years. We want to be able to be open and flexible and move to vendors as we want. In other words, you get captured into a vendor if you don't do it this way.
I agree. If everything you'll see about what I'm doing is based on that, and I've came out of the industry, but I also disliked it. I didn't like the fact that you got locked into things. So not only is the software open, but even the hardware platform. What's fun is we've got kids that are hacking the house now, because what we did is we made the safety layer. Yeah, this is like my favorite part of Lumicache, to be honest with you. The fact that we took care of the safety layer, right? And so then, now kids can, or anyone can hack their own house. But but safely without having to worry about touching that AC voltage and such. So
Yeah.
yeah, it's fun, and you know, I love to see some of the cool things that come out of it. The Minecraft example, somebody had asked me to open source the Minecraft code. I did that back in like 2016, I think it was, but I'll go find the code and I'll publish it up on Git, so that yeah.
Zach's son might need that, right, Zach?
That's
my
right.
boys were nuts about Minecraft, and so it was kind of like, oh, you know, like, look, oh, that's interesting. It's like, hey guys, can you load this particular plugin because that gives us an API? And they're like, what's that? You know, just try it. You know, so they load the thing into their server. Next thing you know, a little bit later, I'm like flashing the lights every time the lightning bolt would go off, and they're like, wow.
Yeah, that's just brilliant. I have to take it back to that non-proprietary piece, because Craig, the first time I heard anyone start talking about that was your fifth Indian Witty presentation, which I'll throw a link in the chat to in a minute. But I loved that type of approach to owning your own data and having a single integrated network, saving all that money on the linear footage of cable, which is super expensive. And also just, you know, the redundancy of labor. If you've got everyone running all these systems and all their own wiring, you really are spending a lot of time in a redundant and expensive exercise. But tonight, what I thought was really fascinating was when you were talking about the overlapping real-time modeling and measuring again, and identifying performance gaps. And I'm wondering, how will you show the teachers or the facilities folks how to use this? And then how will you use it for feedback once the user behavior starts to come in? Like, right, you know, you see everybody, like the spike in CO2 that you showed. Okay, there's a crowd of people and maybe the ERV didn't kick on or something. But what about when it's the user doing something not so passive, right? Not so passive, house friendly. Did the architect or did the community become part of the design process? Or will they become part of the instructional process afterwards? Is there a plan for that?
Yeah, there is. And we basically, when we finish up these Passive House projects, we write a Passive House user's guide. Because, you know, when you get building owners coming in and they're in a Passive House for the first time, you know, their tendency is turn off all the ERVs or turn off your ventilation system to save a little bit of money. They just don't understand the building they're in, that they don't have to do that anymore. So it starts with us educating them on how to operate a Passive House, first of all. And then it moves from there into how to understand the data that you have in this building. And it's not too complex because a Passive House makes us simplify that on purpose, right? We reduce our loads, which means we decouple and we reduce our systems. It makes them much easier to see. And the point I made early on is we want to give them the data that they understand. They're not going to understand kilowatt hours and they're not going to understand kilowatts. But if you show them site energy use intensity, they will understand that. Now I need 12 months to get to that data. So we use simulation as our context. And all they really need to understand is if my building is underperforming or overperforming my sim, then I need to do some sort of action. If it's performing within 20% of that sim, we're good to go. And that's really kind of how we educate them, is that you don't have to understand the context of 90 kWh. You just have to understand the concept. Are you trending near the line of simulation? Because it's going to be this, right?
And what's your experience with how closely they match?
On the energy side, well, I mean, we've been doing this for probably 4 or 5 years. And since COVID, all of our buildings are super performing because they're all underutilized. So we really haven't had that challenge. But for the most part, the energy usually trends pretty close when we do an IES model in a Passive House. You know, let's imagine, even if I miss my 14 EUI by 10% or 15%, you know, it's a nominal delta. It's not like I'm missing 150 EUI by 15% where it's, you know, much bigger. So the idea here is the energy, the variability on energy is much less impactful because of the loads and where we're at in our performance. It's getting at temperature, humidity, and CO2. They can start to adjust a little bit. But once we operationalize the model, we get it tuned pretty closely.
Perfect. Thank you so much. You're the only one I know doing this, and not only doing it now, but have done it for so long. So to have that body of knowledge and have you share it the way you do with this community is really a gift. So I appreciate it very much. We have one more question from Jeffrey. Jeffrey, would you like to unmute?
Yep. Hi, Shannon. It's Jeff from Rideau Ferry, Ontario. Like everybody else, just a great presentation. And Craig, love, you know, the use of the simulation, et cetera, and also some of the sidebar conversations. And one of the ones, not to start off, you know, basically too negatively, and I don't mean it this way, but I have spent my engineering career in the automotive industry, the crashworthiness, et cetera. And just related to the modeling and simulation, one of the thoughts that jumped into my brain when you're just talking the last couple of seconds is, you know, on a building this size, I guess it's, you know, on the modeling size, you know, one would expect that you need, you know, that you will need to go back, do you think, to go in and basically look at your modeling as well, because the reality of the data is the data, right? And so, and I was just also thinking that the cool thing about what you're doing and your approach is, you know, what you built is what you built. It's actually for the next project. And I haven't heard you guys talk about that, but I'm assuming, you know, that's going to be an element of what you're going to do. So that's a comment. My question was, I don't really understand because I'm new to some of this stuff, and that you talk about the zero energy. And I think that's one of the goals, but I haven't heard any discussion about how in a building of that size, where does the balance come, or where are you going to get your zero part of it, right? I mean, the energy is coming from someplace, you know, that you talked about solar panels, et cetera, but you know, that there hasn't been any discussion about that, and just wondering what plans you have for that.
Yeah, that is a good question. We do have a goal of zero energy. Whether or not we reach that as a result of this project, or we reach that in year 2 or 3 or 5, remains to be seen. We do have plans for photovoltaic on the roof. We don't think we'll zero out from that. There are opportunities within the city of Pittsburgh to do a community-based renewable for photovoltaics, and we're looking at that as well. Short of that, you know, we're just trying to remain opportunistic and see what other opportunities we have to zero out. We don't have that solution yet, Jeff. We have the passive house solution, but we don't have the renewable solution yet.
Well, I think you have the passive house, you know, the standard, you know, and the approach, and obviously it's just great. I mean, anything to reduce the energy. And the other thought that I had was just listening to it about the students and the educational side of things. You know, just as an observation, data is data, and it can become absolutely the overwhelming, and it can be, you know, the confounding to the point where it becomes overwhelming and people lose interest in it. And where I'm going with this thought, Craig, is just the idea that, you know, somewhere along the way, conservation will have to come into the educational process, et cetera. You know, it's one thing to be able to note information and data, but I would have thought, as engineers do when we're in the automotive world, that you get the data, and then now you want to take action to try to either improve it or to make the change. And again, I'm just blown away by the challenge that you guys have taken on, when in fact, you know, that you have a building that's pretty much set in stone, if you know what I mean. I mean, it's built, it's there, you've made all of your hard choices, et cetera, et cetera. And more just to say, I think it's just going to be really exciting just to see from an educational perspective how this plays out. And again, just applaud you on your, you know, on, I'm going to call it the systems, you know, basically systems integration and the systems engineering approach, which in the auto industry has been the buzzword for the past 20 years. But ultimately, what we've learned on many of the projects I've worked is that after 4 or 5 years, there will probably be a small number of the parameters that everybody will basically, you know, iterate to, and you learn pretty quickly that those are the guys that you got to watch, you know, and basically the monitor. And I think when it's launched, it's always exciting, but just looking to the future is, what do you do in 5 or 10 years when frankly, all the data is pretty old, you know, and you've got this building dialed in, you've got it tuned in, et cetera. Where do you go? And so my head goes towards zero energy. What do you do to conserve? What do you do to improve the performance of the building, et cetera? But just thoughts. I mean, it's not criticism. It's just fantastic stuff you're doing.
Thank you. Thank you for sharing your thoughts.
And I thought that was the last question of the night. It was a great question, but there is another Jeff question from Jeffrey Rodan again.
I don't know, hopefully I'm not the last, because I know hopefully that, it's like these questions, are more in line, but I think what you're doing is great. You're collecting data in a way. I used to be a software engineer, and there was a database software engineer, and there was a saying that applications come and go, but data lasts for 1,000 years. And I'm wondering, have you had conversations with organizations like one of our sponsors, NYSERDA, and from where I live, there's DOER that's doing a lot of work, and also the Massachusetts Center for Energy, and it's something like that. But anyways, are you talking with those guys to make sure that the data is available and is being stored in a form that's shareable by basic, data interchange standards?
Well, yeah. I'm not sure that NYSERDA can answer that question. First of all, we've done work in those areas, but NYSERDA is not part of our stakeholder community. What we have done is we have the City of Pittsburgh is one of our stakeholder groups. They have energy disclosure ordinance. We'll be able to comply with that without any manual effort whatsoever in our buildings. We do have other sustainability, SES, if you will, Sustainable Energy Funds, and energy groups around the Western Pennsylvania area, and we've engaged them in conversation. I can assure you that our platform can take data from over 450 common protocols of operational technologies and meters and sensors, and we can deliver data to the same thing. So sharing data out from our platform, that's not an issue. We can share that anywhere. We can share that with universities and other stakeholders. So that's not a problem for us, but we do agree with you that the key to this discussion is getting the data, democratizing the data, and getting the data in a safe, secure, and transparent way. What we do with it, we know what we're going to do with it this year, but the analytics environment in that marketplace is exploding. If you go to any of these conferences, RealComm, IBCon, the Niagara Summit, and I've spoken at these conferences, there are rooms full of people writing analytics. So what we want to do is we want to be available for those next analytics, the next generation of analytics and digital twin technology that's coming down the pike. If we have our data, we're available for all that, and we're available for it without being beholden to that vendor, right? We have our data, they don't have our data. So again, that's how we're setting this up, and that's consistent with the best practices in the industry right now.
Right, and what I'm talking about, and I wish I could off the top of my head give you the right words for this, but all of the states subscribe to various data structures and storage protocols.
Ontologies.
What's that? Topologies,
Ontology.
right?
Yeah.
That allow for them to take in data, to analyze the data, and then create policy based on that data.
Right.
And I guess I'm just wondering if you've had those conversations, because I know several people in that area who absolutely would love to talk to you, because they're exactly in the same space and your goals are aligned, and they're the ones that have sort of access to the groups that actually have huge amounts of money to throw behind and further, the common goal.
Yeah, we sort of see the world the same way, Jeffrey, in terms of, if we set this infrastructure up the right way, we could become the example of sort of how to set this up and do it right. And that's why we brought in HEPE and Newcomb and Boyd. And Newcomb and Boyd, if you haven't heard of those guys, I mean, these guys are the preeminent designers for system integrations. So these guys are incredible, and they've kind of given us a lot of guidance in the space. But what you're talking about is ontologies, and the ontologies are really being written around like AWS, Amazon, being written around Google Analytics, and being written around Microsoft Azure. Those are the three gorillas in the room, if you will, that are really kind of coming out and developing those ontologies. But then you have other places like the Digital Twin Consortium, and we're part of that group, and they're identifying the connectivity of that data across platforms, and that's kind of the approach we've taken here as well. So yeah, we're definitely set up in that for that discussion.
Great. Well, your contact information is in the chat. I'll just share that with my network, and you guys can go do the voodoo that you're doing, which is great.
Yeah, and that's the whole thing here, is that I think that the entire passive house community has perfected building science. And as soon as the passive house community starts to figure out how to get into the data science conversation, then this process becomes a scalable process. The building science is scalable, but the problem is you have your skeptics out there saying, yeah, but, yeah, I hear you, but, how many of these buildings are operating at that level? But until we can basically show them that feedback loop and that proof that our buildings are operating a 14 or 15 site EUI, and they're doing it consistently from the meter and not someone showing me a spreadsheet and manipulated data, then all of a sudden we have the proof that this is actually working at scale. And that's our whole goal here.
Right, and fundamental underneath all of this stuff is this data integration layer and sharing of data, because that's where, essentially the rubber meets the road, from where the people with the money, they need to see the analytics behind it. And it's not the analytical tools, which is what the software tool guys want to control. It's about the data itself and making sure that that's available to the widest audience possible.
Yeah, we completely agree.
And that's legible, right? I mean, it doesn't matter if you have it, if you don't understand it, or you can't decipher it, or if you don't have that projected modeling, that projected use to lay it on top of in that single pane of glass like you do. That is just critical.
Well, Shannon, that's the reason how we got here, by the way. If you think about it, it's like we have all this great dynamic sub-hourly data for all the trends that we want. And when we started doing this 6 years ago, we said, okay, let's go to the proprietary BASs, time Mr. Johnson control, and automated logic. And they're laughing at us like, no, we don't do that. We're not interested. So I can't put the data there. Then I went to the digital twins and said, okay, can we put the data with you guys? Yeah, you can, but you can only give me 1 or 2 trends. It's like, no. I want to give you a 1,000 trends, right? Because I want to start doing interrogation. Oh, well, we can't do all that. And then we said, you know what, the problem is solvable, but it's not solvable in the SAS market as it currently exists. We had to go to the independent data layer. And now all of a sudden, if you go into like the RealComm conference, for example, we have a whole panel curated just talking about independent data layers. That's where the puck is going. That's where this whole industry is heading. And we basically had figured it out because we had to. It's like we couldn't go left and we couldn't go right. We had to go here. And when we went there, everybody else is starting to realize, okay, the independent data layer is the solution. And it's a solution that makes you future-proof, right? Now I can go into any advanced data analytic layer I want. I can go into SkySpark, the next SkySpark, the SkySpark after that. And we can do that with no pain. We can do that with no loss in infrastructure or data or anything.
So,
exactly.
Craig,
Now, see, how are you attaching this to the digital twin, and how do you see it reporting out in order for cities to use this? Almost like anonymously, to achieve our 2030, 2050 goals, because that's the big thing that I really just become obsessed with.
Right, and it's more than that. So think about lead ARC. When I want to plug into LARC, I'm doing it. When I want to plug into Reset Air, because Reset Air demands that they get our continuous data given to them, I'm doing it. Then all of a sudden you have the reporting through the 2030 district. We're doing it. And then well building, we're doing this. This is a pilot for well performance rating. So we're doing it across all these disparate platforms. And if we didn't have the independent data layer, it would be impossible to do that. And now all of a sudden the digital twins are coming out. We don't care about digital twins because of digital twins, but if a digital twin can solve a problem for John and get into and do like an elevator concierge because they don't want to hand keys out anymore, then all of a sudden that digital twin has value. If our digital twin wants to do metadata on a maintenance CMMS system for changing filters and everything else, now all of a sudden we can plug that in, like plug and play like you would in the iPhone, and get to that data layer very, very quickly. That's the whole object here, is like this future-proofs our data for us.
Exactly. And it keeps everyone from retiring these amazing digital twins, which have all this data attached to them already, whether they're prefabbing or not, and they're dying at project closeout. And here we have the opportunity to attach more data to them and use them as this maintenance tool. I'm sure you've seen the software that Autodesk just put out, which is Tandem, which looks like really a more maintenance kind of pseudo digital twin.
Well, the BIMs call themselves twins, but they're not really twins.
No.
They're doing metadata in 3D, but they're not giving you a virtual environment like a time series environment.
Exactly, and it doesn't get any more proprietary than that.
Right.
So can I
And
ask
again,
one
you're
more?
back into an SAS.
So
Yeah,
can I ask one more like really data like oriented technical question, which is the data dictionary. Is that something that you share, and how common are your definitions with other industry data dictionary standards?
So if you're talking about data dictionary in terms of like a point naming scheme or point security and data security, we typically use anything that's like market driven, like a brick schema or a haystacks. If you're familiar with haystacks, those are more common data time series protocols that you can set data up and then use them in multiple type systems. Security is multi-level. There's no one answer to that. Like just do this and you have cybersecurity. You have to manage that literally from the edge at the operational technology through data aggregation, through data layer, and then through the analytics. So that is something that is really, really wide and across each of these elements. But in terms of point naming schemes and things like that, there are standards out there like the brick scheme and the haystacks you can use to solve for that.
Right. And so, and you guys have like built that into your data schema designs and that kind of stuff. I know I'm talking at a level of data definition,
cool.
which is really in the weeds if it's not, you know, in the roots.
So no, Jeff, I mean, the question's a great question because a lot of people who don't understand how to get into this space, we did this before we learned that. And we learned the hard way that you need to get into a robust independent data layer like an OSI soft PI system that helps you manage all of those and distribute the data really quickly and easily. And then it's a matter of templatizing it. So once we did it once in our one project, we were able to templatize Haystack,
Okay.
and now we push it against all of our projects, and we can use that to access any of that stuff.
Good.
So yeah,
And-
it's an important question for sure. And if you have the right engineer for your Division 25 system integration, they'll have those standards and specs kind of written out for you as well. So like I said, we work with Newcom and Boyd on this space. These guys are phenomenal, and they can help you to the extent you're on a project, figure that out if you're not working with someone that can do it from a vendor perspective.
Well, I definitely have some people that I think you would be interested in talking to then on this
Sure.
subject.
Yeah, that'd be great.
and
Hey,
that's what
you know, we
makes
talked
this
about the
community
energy thing.
amazing. Derek, Jeffrey, thank you so much for giving back to so much of what Craig gave us and John gave us tonight.
Yeah.
Did you have one
There's
more
a-
comment, Derek, before we
I was
wrap
just
up?
going to say, yeah. So here's an interesting trend that's happening. The energy, thanks to your guys' passive house, you know, principles, the energy consumption is getting so low in these buildings that the control systems are consuming more energy than some of the buildings. and this is such a real issue, by the way. Everything from MELS, which is miscellaneous electrical load, so all these billions of little IoT devices, each one consuming only, you know, 0.2 watts. It's adding up. It's adding up so much that I've been asked to speak at a DOE event next month that's specifically around the base load problem that all of these MELs are adding. It's kind of like when Energy Star got around set-top boxes and things like that that used to be consuming, you know, 20 watts idling, and why we have such great Energy Star, you know, minimum or you know, standby power regulations now. So you're getting into the same issue, and while all the talk about, you know, collect the data points everywhere is fantastic from its benefits, you know, what you're starting to see is that people like you, Craig, are proving that, like, okay, we know that this is how the building should be built. And so if we just build buildings that way, we don't have to do quite as much modeling. And so I think that there's going to be a peak in just a few years as far as the amount of data that we collect, because at some point we're going to have to totalize how much energy are we storing in the collection of the data. And it's actually pretty sizable. So just kind of keep that in mind too, that you also have to reduce the amount of energy of the collection system itself.
Yeah, that's fair.
Yeah.
That's a good place to stop. And I'm gonna invite everyone to save the chat by clicking on the three bottoms on the lower right. please thank Craig and John again. Connect with them on social media or through email and take a look at that presentation for Fifth and Dinwiddie, because that was the precursor for me that got me hooked on reset and thinking about digital twins, monitoring, and single panes of glass, all these great buzzwords. And it's got more acronyms, I think, than any other presentation. We had an acronym-a-thon that night.
I tried so hard, Shannon, to not go
so
down
good.
and use acronyms.
You did a great job tonight. I think I only put one definition in.
I think
Thank you,
John
Craig.
beat me on acronyms with FD&D. But Shannon, thank you so much for letting us speak. Thank you, Michael, Zach, the whole group. I love this community, and we're glad to contribute to it. So thank you, guys.
Our pleasure. We'll hope to have you back again soon and sharing more data.
Absolutely. Have a good one.
Good night, everyone.